This is section 8.2, part B, constructing a confidence interval for P. When the standard deviation of a statistic is estimated from the data, the result is called the standard error of the statistic. How do we get the critical value for a confidence interval? If the normal condition is met, we can use a normal curve. We can get an accurate critical value from table A or from a calculator. As the below figure shows, the central 95% of the standard normal distribution is marked off with 2 points. We have a z-value of negative 1.96 and a z-value of 1.96. Now these are referred to as z star, and we use the star to remind us that this is a critical value, not a standardized score that has been calculated from data. To find a level of confidence interval, we need to catch the central area C under the standard normal curve. Here is an example that shows how to get that critical value Z star for any critical level. So use table A to find the critical value Z star for an 80% confidence interval. Assume that the normal condition is met. So when we're looking for an 80% confidence interval, we need to catch the central 80% of the standard normal distribution. So if we have a normal curve, and we want to catch the middle 80% of that curve, we know that there's 20% left on the two sides. Now, if we divide this by 2, we know there's going to be 10% left on each side. So the desired critical value Z star is the point with an area of 0.1 or 0.10 to the right, and it's to right under the standard normal curve. So if we look at our piece of table A, we are looking for an area of 0.10. The closest we're going to find is 0.1003 or 0.985. Since 0.103 is closer, we would use that value and we would work backwards. So we would find the z value that corresponds. So if you work to the left, you see negative 1.2, go up, you have 0.08. So that's going to tell us we have a z star value of negative 1.28. The other value would also be a positive 1.28 because it's going to be the same distance from the ends. So our two values would be negative 1.28 and a positive 1.28. But when we're talking about the critical value, we're always going to use that positive value. So the critical value we would want would be z star is equal to 1.28. And remember that critical value is telling you how many standard deviations away from the mean this would be located. So when we were talking a 95% confidence interval, that value, or z star in that case, was 2 because it's 2 standard deviations away from the mean. When we're talking 80% confidence interval, now we're saying we're within 1.28 standard deviations of the mean in either direction. Once we find that confidence value, z star, our confidence interval for the population proportion, P, is our statistic plus or minus the critical value times the standard deviation of our statistic. And remember, to find the standard deviation of the statistic, since we're talking about proportions, is the square root of p hat times 1 minus p hat all over n, or the square root of our probability of success times our probability of failure all over the sample size. So you're going to do your sample statistic, or your p hat, plus or minus that critical value z star times the standard deviation of the statistic itself. Notice that we replace the standard deviation of p hat with the formula from the standard error. The resulting interval is sometimes called a one-sample z interval for a population proportion. When you choose a simple random sample of size n from a large population that contains an unknown proportion p of successes, an approximate level C confidence interval for P is given in that form. But remember, Z star is the critical value for the standard normal curve, with an area C between negative Z star and positive Z star. Use this interval only when the number of successes and failures in the sample are both at least 10 and the population is at least 10 times as large as the sample. So Mr. Smith's class took a simple random sample of beads from the container and got 107 red beads and 144 white beads. Calculate and interpret a 90% confidence interval for P. So if we're doing a 90% confidence interval, that means 90% of our data is inside, and that means 10% is outside. If we take the 10% and we cut it in half, that means we're going to have 5% on each tail. So if we have 5%, that's a 0.05. You would need to go to your table and you would need to find an area that is closest to 0.05 to find your critical value. In this case, our critical value, or our Z star, would be between negative 1.64 and negative 1.65. In this case, since it's exactly halfway between negative 1.64 and negative 1.65, we can actually use the value of 1.645 as our critical value. If it wasn't exactly halfway between, we would just have to pick one or the other, or we would have to use our calculator to find that critical value, so it's more accurate. The resulting 90% confidence interval is going to be our p hat plus or minus our Z star times the standard deviation. So because we had 107 out of 251, that's going to give us our p hat of 0.426. We're going to do that plus or minus our critical value of 1.645 times the standard deviation. Well, remember, the standard deviation is the probability of success times the probability of failure all over the sample size, and it's the square root. So this is going to give us 0.426 plus or minus 0.051. And if we subtract and add that, it's going to give us an interval of 0.375 to 0.477. So we are 90% confident that the interval from 0.375 to 0.477, or 37.5% to 47.7%, captures the actual proportion of red beads in Mr. Smith's container. Mr. Smith's class took a simple random sample of beads, and it had 107 red and 144 white beads. Now, Mr. Smith claims that it actually had half the beads in the container were red. Use your result from part A to comment on this claim. The confidence interval in part A gives a range of plausible values for the population proportion of red beads. Since 0.5 or 50% is not contained in the interval, we have reason to doubt Mr. Smith's claim. Now let's check our understanding. Alcohol abuse has been described by college presidents as the #1 problem on campus and is an important cause of death in young adults. How common is it? A survey of 10,904 randomly selected U.S. college students collected information on drinking behavior and alcohol-related problems. The researchers defined frequent binge drinking as having 5 or more drinks in a row 3 or more times in the past 2 weeks. According to this definition, of those 10,904 randomly selected students, 2,486 students were classified as frequent binge drinkers. Identify the population and the parameter of interest. So in this case, our population would be all U.S. college students. Our parameter of interest is the true proportion who are classified as binge drinkers from all U.S. college students. Check conditions for constructing a confidence interval for the parameter. So remember, we need to check random, normal, and independent. In this case, for random, it does tell us that the students were chosen at random, so this is met. For our normal, we need to make sure there's at least 10 successes and at least 10 failures, since we are looking for a proportion. It tells us that 2,486 students are considered binge drinkers. So the remaining 8,418 would be failures because they are not binge drinkers. So both of those categories are at least 10. To make sure that it's independent, we need to make sure the 10% condition is met. And 10,904 is clearly less than 10% of all U.S. college students. So all 3 of those conditions have been met. Find the critical value of 99% confidence interval, show your method, then calculate the interval. So for a 99% confidence interval, that's only going to leave 1% for the two tails together. So if we cut that in half, it's only going to leave you with a 0.5% for the tails. So if we look at table A for 0.005, we're going to get between negative 2.57 and negative 2.58. So if we split the difference, that's going to give us a critical value of 2.575. And remember, that critical value will always be positive. We know that our p-hat, or our sample proportion, is going to be 0.228 because we know our number of successes, our number of bin drinkers, and we know the total population, our total sample size. To find our interval, we're going to do our p-hat plus or minus that z star times the standard deviation for the sample. So we're going to take our p-hat plus or minus our critical value and then multiply it by our standard deviation. Remember, that's the square root of the probability of success times the probability of failure all over the sample size. And this is going to give us an interval of 0.228 as our p-hat, and we're going to do plus or minus 0.010, or it's going to give us an interval of 21.8% to 23.8%. Interpret this interval in context. So we are 99% confident that the interval from 21.8% to 23.8% captures the true proportion of U.S. college students who would be classified as binge drinkers.